Hello student, today we will be solving the IB Math A AGL May 2025 paper 2 times on 2 question number 5. You will be getting the solutions for the first 4 questions from this paper and the solutions to the other questions from the other past papers in form of playlists on my channel NS Online Math Tutoring classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I'm an online IB Math A age level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve the question number 5. The maximum mark is 7. Particle P moves in a straight line. The velocity v meters per second of P at time t seconds is given by v of t equal to e raised to the power of negative sine t times cos of 2t for t greater than or equal to 0 but less than or equal to 5. So part A's question is find the maximum speed of P. Okay. So maximum speed or speed is equal to the absolute value of the velocity. Okay. So maximum speed will be when this value is the maximum. So let us graph this. First of all, let us just save this expression because this is the total distance required. For this we have to use the integration, so we will be needing this expression multiple times. So first of all, let us save this expression. Okay, it is e to the power of negative sine, and I'm writing x because I have to graph also, so it's better to keep it as x times cos of 2 times x. Okay. Yes, I could have kept this as t and I could have named this as v of t, and if I write v of x, the t's will be getting changed to x automatically. But I have written x in place of t, and I'll be naming this as v of x. Okay, you can keep these as t if you want. And I'll be saving this, so it is control and this var. You are seeing this is in red written as stored. So var, this arrow appears, and I'll be keeping the name as v and x. Okay, and enter. Say it is done. That means it has got stored. And now I go to the graph, and now I will be graphing the absolute value of v of x because I need the speed. So, and var, it is this, and it is x. Okay, enter. And I know that t is between 0 to 5, so let me change the window settings. So it is between 0, so let me take it as -1 so that I can see the y-axis, and this will be 5. Okay, and the maximum value is over here, and see. Okay, so I have to get the maximum. It is this. Fine. And the x value represents the time, but they are asking for the speed, so we have to take the y value. Okay, so it is 2.718. So correct to 3 significant figures, it will be 2.72 meters per second. And we can give the graph, or if it is difficult for you to draw these and it is containing just just 2 marks, then okay, we can say maximum speed is when is maximum Using GDC graphs, the maximum points coordinates are 4.71. I'm taking correct to three significant figures. 4.71 and 2.72. Okay. Therefore, the maximum speed this is also correct to three significant figures. Okay. Therefore, the maximum speed is 2.72 meters per second. Okay. So part B, find the total distance traveled by P. So, part B, total distance equal to T is between 0 to 5. Since it is the distance, it will be the absolute value of V and dt. Okay. So, this is equal to 0 to 5 absolute value of e to the power of negative sine t times cos of 2t and dt. Okay. So, calculator. Okay. Integral 0 to 5 and we have the expression stored. So, again the absolute value and this is V x and this will be x because I have taken V of x, therefore I am taking dx, not dt. Okay. And it is 3.8459. So, correct to three significant figures, it will be 3.85 meters. Okay. 3.85 meters correct to three significant figures and this also correct to three significant figures. Okay. So, part C, find the acceleration when P changes direction for the second time. Okay. So, P changes direction when V is equal to 0. If it is moving in the towards the right, maybe the V value is positive. If it is moving towards the left, the V value is negative because it is moving in a straight line. I am assuming that it is moving in the right left direction, not up and down direction. So, P changes its direction when V is equal to 0. Okay. So, we have to graph, now we have to graph this v of x, not the absolute value. Okay, so because we have to see the time when it is changing its direction for the second time. So graph, and this time it will be just v. Function, it is v and x, v of x. And we have to change the window settings, it is maybe -1 to 5. Okay, fine, we have got the graph from -1 to 5, and we are seeing that it is changing the direction first over here and second over here. So we will be getting the this time. Okay, so this 0. So menu, analyze graph, and 0, and it is this one. So the particle P is changing its direction for the second time at 2.356 seconds. Okay, 2.356 seconds. P, according to GDC graphs, using GDC graphs also you can write. P changes its direction for the second time at 2.356 seconds. Okay, and we have to get the acceleration. So acceleration is equal to ddt of v of t at t equal to 2.356 seconds. Okay, so this is what you have to get. So you can find the value in both ways. I can show you both the methods. This is the graphical method. We have graphed the velocity function expression. So I need the value of the acceleration at this point. So you can use the menu and then analyze graph, and it is dy dx, at which points it is saying position. So it is this position. So I have clicked over there, and the acceleration value when t is equal to 2.356 seconds is 0.986. Okay, if you want to be extra sure, then you can use the nsolve also, not nsolve, but the algebraic method, this calculator page, you can use the calculator page. So it will be the first derivative, it is with respect to x I'm taking, and it is v of x. Yes, and I have to give the x value. So it is control, and this is the vertical line known as the pipe, and I have to give the value of x, which is t. So this x is equal to 2.356 and enter. See, 0.9858. So correct to three significant figures, it is 0.986. That is what we had got, 0.986. Okay. So correct to three significant figures, the acceleration is 0.986 meter per second square. Okay, is equal to 0.986 meter per second square. correct to three significant figures. So we have completed solving this question. Thank you for staying with me till the end. Please like and share my video in case you have liked my explanation, and please do subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. We meet again very soon in our next session. We'll be solving question 6 of the same paper. Till then, bye.